Welcome to this talk today about security architecture today and tomorrow, featuring some trends. I was really excited by the keynote yesterday because I thought it was, one, excellent, and two, feeds really, really nicely into my presentation. I think they complement one another, so I was really excited by that. So if you feel like there's a repetition in themes in some portions here, it's from two different aspects, and I think that's really important to get two different views on the same problem. So yay! A little bit about me. My name is Siren, in case you forgot. I'm the head of security at Min Doktor. You can follow me at Twitter. If you feel like you like Twitter, I tend to answer questions really fast. I am a security enthusiast. I don't like the word expert, so I am an enthusiast about security. I love my job. I really, really love my job. And my one teeny tiny sales pitch for this entire presentation is my user group called SecuriTea. We're down in Skåne at Foo Cafe. It's free. I've made it my personal crusade in life to try and get more security people, or more people into security, from kind of a human low level. If you've never worked with security before, come to SecuriTea. We're a new people group. Doesn't cost any money. We have free pizza and free beer. So, exactly, woohoo! I remember how terrible it was when I started in security a long, long, long time ago. So I started SecuriTea as kind of a way to get more people involved in a space that feels really welcoming for them. So if you want to get into security, if it's something you want to do, come to my user group, we will help you. That is the only sales pitch during my entire presentation, I swear. That was it, I'm done. In the beginning, when I started in security, one of the biggest shocks in my life, because I started as a penetration tester, was that I thought I was going to find new bugs. I thought that I have now discovered cross-site scripting, SQL injection. I found all these bugs. This was an embarrassing amount of years ago, and I thought that I was going to be done. I thought that we'd learned our lesson, and that now as I grew as a security person, and I thank God matured, I would be finding new bugs. And it is one of the biggest shocks of my career that that has turned out not to be true. And so I started to think about this, like, why aren't people learning? Why are we still making the same mistakes? And I didn't really have an answer to that question, which has bothered me for many, many years, because I kept finding the exact same types of bugs. I kept finding the exact same types of mistakes in architecture, and I couldn't understand why that was. And security has, since the dawn of time, been trying to solve a couple of very fundamental questions. The first one is, who has access to your data? Who can see it? And it's a fundamental question that businesses and private people are asking all the time. Who can see this picture of me? Who can see my data? What is it being used for? Another question is, whose fault is it if a mistake happens? Is it the business's fault? Is it my fault because I had the same password everywhere? Is it the government's fault? I mean, who can I blame? Who can I shake my fist angrily at? Who can I came from the United States, so obviously, who can I sue? It's true. I apologize. But, and that's kind of where we want to, whose fault is it? Because we as people, myself included, like to blame someone, preferably not ourselves, because it's never my fault. So where is my data exactly? And this becomes particularly important under GDPR, where privacy and data concerns are paramount. So where is my data? Is it in the United States, where the NSA and the FBI and the CIA are personally handing it to Trump? Is it in China? Is it in Russia? Where is my data? Seriously, where is it? What else is stored next to my data? If I can stuff a bunch of nasty, injection attacks or other types of nasty into your database, is that going to affect my data? How is my data kept sane and clean? Will my data survive a disaster? If a meteor crushes your business tomorrow, will the data survive? And it seems like an absurd statement because meteors, thank God, don't happen a lot. But fires do, and floods do, denial of service does. A database can fall over and just die. What happens to the data? How are we solving that problem? And finally, and this is the most boring question of all, who can audit your data? Who makes sure that you're actually doing what you say you are? And I know that's a dull question, so we're just going to hop right past that one, because it's boring and dull. But it's an important one to know. Who is actually keeping you to task? So it's an interesting thing about how we learn. MIT did a study on monkeys. I'm not exactly sure of the year, but you can check it out. It's a study that they did on the way monkeys remember things. And they looked at the way a monkey's brain fired when doing something right versus doing something wrong. And the neural pathways in the monkey's brain fired for a longer time when the monkey did something correctly. And it was a shorter amount of time when the monkey did something incorrectly. And the hypothesis, or the end of the study concluded that the correct action was actually kept in a type of memory buffer in the monkey's brain, so that every single time it did a correct action, the brain would give it a positive feedback. So it became easier and easier and easier to do the right thing because the monkey's brain had a better and better and better neural pathway. So what our mother said 1,000,000 years ago was practice makes you perfect is actually scientifically proven, which is interesting because it means that the inverse, doing the wrong thing, your brain has a harder time remembering that, and that sucks. Because the study also said that we're scientifically rather close to monkeys, which means our brains, in all likelihood, work in a similar fashion. Which brings us to this gentleman, George Santayana, and I'm probably butchering his name, so I apologize to the gentleman. He died in the 1800s, so I don't think he's going to kill me. But he is the author of the quote, "Those who do not remember history are doomed to repeat it." And now we have the scientific evidence of why that is true. Our brains are actually built to make sure that things that we do well, we remember, or things that we do poorly, it's actually more difficult to remember. And this becomes really interesting because this is the speed at which we develop. And so we just kind of plow over our mistakes as we rush, like in a headlong rush forward. And now we understand that there's a scientific reason. So again, it is not my fault, it is my brain. Yes, I have won, we are done. So now you're just like, this was supposed to be about security and architecture, and she's babbling about monkeys, and I don't care. And we're going to get there. So this talk was born out of rage from me. I love architecture, and I love what I do, but it scares me that people don't tend to think through their mistakes. And this is most prevalent when we're looking at Bitcoin and blockchain. And people have, let's say, not always expressed the interest in security that I think everyone should have. And this is becoming especially true, and from my perspective, especially frightening when we're looking at blockchain and Bitcoin. So this is a beverage company called Long Island Iced Tea Corp, and another one called Sky People Fruit Juice. And on the 21st of December, they saw their stock increase by 500% by adding blockchain to the name. 500%. That is insane. And on my Twitter feed, I got really, really excited for one whole day because I saw hashtag crypto was trending. And I was like, yes, the security trend is coming, and it was Bitcoin. And I was like, damn it, sorry. And I was really excited, but then I realized that the reason people are excited is because we all secretly want to be wealthy, myself included. And so we see this as like, now we can make money on a new cool architecture trend. And for whatever reason, Bitcoin and blockchain have been assigned the security tag. So now these two new technologies, and Bitcoin isn't actually a technology, for those of you who don't know, are going to solve security. And I bring back kind of what I said a few minutes ago, is that I've been doing this for a while, and I keep seeing the exact same mistakes over and over and over, and my fear is that this one, it's going to be worse, because now our stock price can increase by 500%. They still made juice. They didn't add blockchain. They just added the word. So this is just my personal little fear here. So if you're wondering where the inspiration for this talk came, it was juice. Now, for those of you hoping that I'm going to give you the secrets of investing in Bitcoin so that you too can be a millionaire, I'm going to disappoint you immediately and say I know almost nothing about Bitcoin. I know it looks like that in the pictures. I know what it is, and I know that I've blocked almost everyone on Twitter that talks about it because it bores me. That is my rant. So this is, for those of you who don't know, the Enigma machine. I was also a little bit interested that I'm not the only person that does history and technology. So this is the Enigma machine that the Allies broke to decrypt the German traffic. And it was presented in a movie called The Enigma Game, or The Enigma Game, I think that was it, played by Benedict Cumberbatch. I also Imitation Game, thank you. What did I say? Yeah, anyway, I said it wrong, but that's the right number, so thank you. And it was presented by Mr. Cumberbatch. and he was broken by a man named Alan Turing. And he wasn't the only person that did it, but in the movie he was. And what's interesting about the Enigma machine was that from a technology perspective, for its time, it was actually very good. So I'm going to talk a little bit about the Enigma machine. And the Enigma machine actually didn't use a single key, as presented in the movie. It used two. So every single day, the operator for the Enigma machine would use something called a day key. And then there was something called a message key. And the day key was used to encrypt the message key. And the message key was in turn used to encrypt the message. So each packet was actually two separate keys. So we have a first key encrypting a second key, which is encrypting the message itself. Now, for those of you that are interested in cryptography, you're like, that's actually pretty smart. From a design perspective, that is not stupid. Now, you can't sit there with your cloud super engine of, crushing, because, you break it today easily. But you have to remember, this is the 1940s. Two keys like that, encrypting each other, that is very clever. But in the movie, they didn't really cover that aspect. But I want to talk about it because we're talking about the person that had to do the day key. And the day key was the key to everything. And it was a 5-character, and it was supposed to be random. So you have a person that probably in the beginning, random keys, random keys, random keys. Now your planes are under fire. Your people are dying. Are you going to sit there calmly, random keys, random keys? Absolutely not. You're going to have the fastest thing you can get because your people are dying. Your brother, your sister, whoever it is out there, and they're dying. So the human error isn't necessarily an error. It's actually incredibly predictable. So the 5-key thing, probably not super random. So that was one problem. Other problem is they ended all their messages with Heil Hitler. Now, also not super smart, if you know anything about cryptography, to have a very predictable something. So you're going to start with something that has a human element. You're going to end it with something very predictable. Cryptography, not super smart, but it wasn't, a eureka moment as presented in the film. This actually took a while for them to figure out. And from a cryptography point in the times, it wasn't poorly done. And I want you to kind of think about that as the back of your head as we go on. So when we're talking about security architecture, I want us to all, for just a teeny tiny second, ponder the question, do you actually understand the business that you're working in? And I would argue that most of us do not. Because we as people tend to get very silo-focused, and we sit with our own area, and so we design things, we build things, we create things from our own perspectives. And we have a tendency when we get busy, and we are all busy, to not talk to the next person next to us. Definitely not in the next department, and definitely not if you're a technologist, to talk to someone that isn't, because they have no idea what you're doing. And they're just sitting there with their whatever it is. And I would argue that most of us, if we understood our business, we would wind up in the fetal position looking something like this. Just because we would realize that we have forgotten something monumental. We have made some monumental whoops, and have forgotten some area of the business that will inevitably affect the technology choices that we have made. So this is another thing, that do we actually understand the business? Do we actually understand what problem we are actively trying to solve when we are building something? And I would argue, from a securities perspective, that most of the time we do not. And there is a very good reason. Now, if you look at classic security culture, what you're supposed to be doing to build good security into your business, a really popular methodology is SABSA. You see it's 6 steps here behind me. And it goes like this. You look at the business drivers. What are we achieving? What are we supposed to do? What are we trying to sell? I am trying to sell pants. Well, that is the business driver. I desperately want to sell you more pants. Okay, what are the business attributes? Well, we're distributed all over the world to sell pants, and that is our attributes. We are X number of people. We have X number of skill sets. Those are the attributes we have. What are the threats to our pants selling business? Do we have a competitor that sells a better model of pants, a cheaper model of pant? Do we have we pissed off a bunch of, nation states, a bunch of other actors, of other hackers? What are the threats to our business? If, the cloth that we chose has gone out of business, whatever the case may be. What is the impact if that happens? If all of our stuff is stored in clear text, if we only have a single database, if we've overworked the sysad to the point that he or she is, has passed out from exhaustion, what are the impacts of the way we drive our business and of the way and how we handle our threats? What are the impacts of those? What types of things are we trying to control? And finally, what type of security services do we actually offer? So with those powers combined, we're going to get a functioning business. And unfortunately, that is staggeringly dull. And no one really has time to do that. It's the right way to do it, and I would argue that most people don't do that because we don't really have time. And security, for whatever reason, and I would argue most of it is a lack of education, doesn't really get to be in the very first room, and it has to be in order to be represented in all of the steps above it. You can't really run into me, before a release and say, hey, could you just check something really quick we're releasing in 10 minutes? I could be a penetration testing god, and I couldn't find everything. Just to be clear, I am not a penetration testing god, just FYI. So we tend to throw the baby out with the bathwater, and all of the good ideas that we've had when it comes to security, when it comes to architecture, tend to be washed away. And we don't think things through because we found the new, exciting whatever it is. Our boss has found blockchain, and if he has or she has, I'm so sorry. Our boss has discovered microservices. I worked for a company when microservices was really big and kind of like a new hot thing, and we literally had a project manager run into the room and scream, "Microservices!" and then just run out. And I was like, I don't, okay. And so we tend to kind of get focused on this is the technology that is going to solve our business problems. But we don't really understand the business. So can we actually solve that problem? And just point of minor, this is a point of minor importance. This wood cutting is from 1512, which means as far as I know, at this JFocus conference, I have the earliest date. So this is 1512, so I think I win. So what was the first problem that we were trying to solve? And as far as I know, from this talk at least, and I know there were others, it was the monolith, here represented by this large square that I stole from Google. And monoliths were large and clunky. They were hard to modularize. They were hard to test. And if you had an API that was, 5 million, lines of code, finding a bug could at times be incredibly difficult. Incredibly difficult. So then along came microservices, and microservices made us a number of promises that I have tried to lie together in this particular slide. And I kind of want to talk about the promise, quote unquote, of microservices. The first promise that microservices made was, number one, it keeps the code cleaner. And I heard this over and over and over and over and over again, and I heard someone snort over there, and I'm with you on that snort. Because I would argue that there's no technology that should be used to justify writing correct code. You cannot say, I will only write good code if it's, the right architecture. That should be a point of purpose for everybody. Everybody should write good code because they are proud of their work. That shouldn't be a microservices thing. It's easier to write things if they only do one thing. Probably true, but distributed transactions are hard. Done. They're faster than monoliths. I'm not going to argue that one. It's easier for engineers to not do all the work, in the same code base. Also true, if we didn't then immediately build a bunch of silos that didn't speak to one another so none of the services could speak to one another. And finally, and this one is true, it is easier to handle autoscaling, and Docker is probably in there somewhere. Or it's some other, docking technology. From a security perspective, you're not really seeing anything on these five points. Security isn't even on the slide. And so when I asked about security, they're like, yeah, but it's going to solve scaling. It's going to be great. You can have modular tests. You can pluck the authentication out and test it by itself. And I was like, that's fantastic. That sounded great. And the problem is there were two very specific security problems, and the first one was the network. If you have 10,000 teeny tiny little microservices trying to talk all at the same time, the network is not going to be happy. And there was a rash of companies denial of service testing or even distributed denial of service attacking themselves with their own services. It was huge. And I know still systems administrators that hear microservices and they get slightly paler because they're just they're white knuckling it. And they're just like, Jesus Christ, I don't know how to handle this. And then the other one was encryption. So if you have a bunch of distributed services, how are you going to authenticate them? How are you going to identify them? And can you run them encrypted on an internal versus external network? I would say most microservices on internal networks today do not run in an encrypted state. And companies that I ask about this, their defense is it's on an internal network. And I say, yes, have you checked? And then they go, get off the Wi-Fi. And then, it's always because it's not, we know they're on an internal network. We check it all the time, and this is how we know. It's they're on an internal network because someone told me so 10 years ago, and our developers know. And I'm like, okay, so you've never exposed an internal resource externally that shouldn't have been. And then it becomes a really awkward conversation because everybody knows what I do. And then it becomes an even more awkward conversation because they try and do this one. And they just try and dodge the question. And so microservices are great. This is not a talk of me just like banging the shit out of architecture. It's saying that they haven't solved 3 fundamental problems. They haven't solved authentication. They haven't solved identification. They haven't solved the endpoint. They haven't solved the server, and they definitely haven't solved the network. But they solved a lot of other problems. But if we go back to this slide, security isn't on the microservices promise, which I always thought was a little weird. So after microservices claim the cloud, and I tried to find the ta-da noise, but I couldn't find it in a free version, so just in your head, could you make that noise for this slide, please? Because I feel like this slide deserves that noise, but I couldn't find it in a free-to-use state, so pretend it's on there. And the cloud solved the storage problem along with a networking problem, because now we didn't have to have a bunch of very, very expensive servers. We didn't have to have a bunch of very, very, very expensive server rooms. We didn't have to have a bunch of very, very, very talented sysads to maintain our very, very, very expensive servers and the server rooms, which are loud, et cetera, et cetera, et cetera. So it solved a bunch of problems, and people were super stoked about this. So I found this super stoked man, free photo. He looked super stoked. I Googled happy person, and I thought he looked the most ridiculous, so I picked him. And it solved us a bunch of problems. But again, if we look at the cloud, the security industry went, wait, stop, where is the data? And people went, la, 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 la. And so in security, we were just kind of shoved into the corner because data centers are super expensive. They are super expensive to maintain. So if we could shove that onto somebody else, that would be fantastic. And so we were just kind of, I'm not going to say ignored, because that would be rude, but we were told to hang on, we're going to get to you. And just hang on, we're getting there. Hang on, just shh. And I'm still eagerly waiting. Now, has the cloud improved since it came here? Absolutely. However, these are 3 stories from October of 2017, all cloud related. And unfortunately, they didn't get back to us being security, not me specifically. And so now we've taken everything that was in our data centers, keys and all, and shoved them into said cloud without understanding said cloud, without understanding our business. And now all of a sudden we have information in clear text, we have keys, we have private information public, and I am not particularly surprised, sadly. I wish I was surprised, but I'm not. And so we're looking at this, we solved one problem, we solved storage, no argument at all. But again, did we solve authentication? Did we solve identification? Did we solve networking? Did we solve the endpoint? Cloud gives us the excellent option to work from absolutely anywhere. I worked from my hotel room last night. It's very convenient. Yeah, from a security perspective, yeah. Now, the last story is the one that should scare us, because crypto coin miners are caught hacking clouds to make money. You remember that 500% rise in stock prices? We can now use the phenomenal power of the cloud to make even more money than what we were making before. And this should scare us, because people want to be rich and famous, myself included, and now we can use a technology to make money, and a technology that we haven't secured because we're finding keys in it, repo keys, code keys, private keys, in open repositories that people aren't checking on, that we can now make money. Even more exciting with the advent of GDPR, which says that you must absolutely know where your data is. Can you tell me if you have your data in the cloud, specifically where it is? Can you point to it? The answer is you can't. Now you can lock it into a cloud that's on the EU, and a lot of people that are working with GDPR are very specific. They say we only host our data in Google Clouds that are in the EU, and good for you for thinking about that, but can you point to your data? And the answer is you can't. Do you know whose data is hosted in the cloud with yours? You don't. If you want to audit your data, try asking Google for auditable logs of the cloud instance that is yours. You will not get a complete log. Google will give you a very good log. We use Google at my work. This is not a diss to Google at all. But they will not give you the entire log because they can't, because it has other companies' information in pieces of it. So they literally can't. So this isn't Google being an evil mastermind, it's Google, they literally can't do that for you. And that is a different risk from if you had your server where you can go over and give it a good kick if it was having a bad day. You shouldn't just, but you could. You shouldn't, but you could. And so this is a different type of risk. And my question is that I cannot answer is, have we thought that through? Looping back, do we actually understand our business? And my argument is still, half an hour in, that we do not. So that leads us to blockchain. The one that I think some people came to see because it was in my little speaker, come listen to me. I'm sure there's some person in here that's disappointed that I'm not talking about Bitcoin. And to that person, I'm sorry. But if we look at blockchain, blockchain is basically a JSON token on steroids. This is not a new technology. And it is not a security silver bullet. It does not solve the world's problems. Absolutely not. Does that mean it is a bad technology? Absolutely not. Blockchain has some really interesting implications for PKI. It has some really great implications for data integrity. I mean, there are some really neat DNS services. I'm going to go with Nebulous. I hope I'm saying that right. That's talking about how we can have a more secure DNS service using blockchain. But if you look at what's being talked about regarding blockchain, it is a silver bullet. It is going to solve all of our problems. And that is different from cloud, and it is different from microservices because the stock prices went up by 500%. And that is a scary, scary concept to me. Because it means that the mistakes that we have made with microservice and the mistakes that we made with cloud, we are going to make them again with blockchain, Bitcoin, whatever the new terminology is, and it changes all of the time. Yesterday, I found out there's a Bitcoin based on the price of ecological bananas. We're going to make them again, and it's going to be worse because stock prices increased by 500%. And we didn't see that with microservices, and we didn't see that with the cloud, but we do here. And again, do we understand our business? And again, I'm going to say we don't. So what is interesting with blockchain is that the security community has divided itself, and we're half and half solidly now. Half and half of blockchain is the greatest thing that I've ever seen, and it is my soulmate, and I will love it forever and ever and ever. And the other half that's like, wait, stop. And this also scares me because it means that people that are trying to learn about the blockchain from security, because it's been assigned as ours, don't really have a good method to listen to us because we're not in agreement. And there's so much hype about it that it's really hard to get good information. So there's a really interesting book called The Conversation, and this is by a professor at Elon University. And she gave some recommendations for people using blockchain or implications for blockchain technology. And this is what she said. She said, continue to use end-to-end encryption apps whenever possible. So Signal for messaging, for example. Brilliant. Stay vigilant about password hygiene. Use a password manager. Brilliant advice. And finally, be aware of what is installed on the endpoint. What is interesting about this is she's talking about blockchain, but this is the advice I would give you for any technology, anything. This is the advice I would have given you when you started, and this was many years ago for me, this is the advice I would give you tomorrow. There is absolutely no difference from a security perspective. And why I'm bringing this up is because blockchain does not solve the endpoint problem. Blockchain does not solve, a server problem. Yes, blockchain could be serverless, but how many of us hand, to God or on a Bible or on a dictionary or whatever, have a serverless architecture? Nearly none. So it doesn't solve a host of security problems. And are we even thinking about that when we're looking at that technology? How do you authenticate? How do you identify? Does it solve tampering? Absolutely. Questionlessly. But how do you protect the endpoint? And we're looking at a lot of the robberies that have been for Bitcoin banks, houses, wallets, repositories, what? Exchanges, exactly. A lot of them have originated, the hacks themselves, from poor endpoint security. So Bitcoin and blockchain, forgive me, does not solve the endpoint problem. And we're looking at security. The two places security is weakest is at the endpoint and at the server. Security is weak all over the place, but it is relatively strongest at the network, where blockchain is. Now again, this does not say that this is a bad architecture. This does not say that it is terrible or anything. But it is scary to see us making the same mistakes over and over and over and over again. So I would say that we tend to handle technology and architecture using this little graph. We figure out the technology, and it's new and exciting, and we get super, super stoked. So we inflate the hell out of the technology. So we burst into the room and scream microservices. We burst into the room and scream, I don't know, cloud, blockchain, whatever the new thing is tomorrow. And then we all start desperately working on that. We throw the baby out with the bathwater. We don't focus on the problems that are actually there because we are so focused on what we can solve. We don't think about what the business needs. We don't think about what the business actually wants. We look at what problem does this architecture solve? Microservices, scalability, cloud, storage, blockchain, tampering network problems. But that does not mean they solve everything. And there's a really great saying that when you are a hammer, every single problem looks like a nail. And this is 100% that. I think I mentioned this before, but this is where security is the weakest. And it is at two particular points. It is the endpoint and it is the storage. And until we solve security in those two particular points, it is going to be really different to have any type of silver bullet, if such a thing even exists. I think this quote is probably the best one I've had for any particular talk. And this is why it's one of my very last slides. And I'd like to read it for you. And its sillies were not a weakness of the Enigma machine. And it was rather they were a weakness in the way the machine was being used. And I said that at the very beginning of my talk, is that there were two keys. There was a message key, and there was a day key. They went like this. I did it backwards. But the problem was the person who was using it. And I think that the keynote speaker yesterday said this very, very well, is that the stack goes all the way down, but it also goes all the way up. And if you're building a technology and you're forgetting the fact that it is a person who is using that technology, then you have not understood the business. You have not understood the problem that you are trying to solve, because it is easy, and it is human, unfortunately, to blame one another. So if we're looking at Enigma, was it the fault of the operator who chose a bad day key? Honestly, I would say no. Was it the fault of the Hawaii missile disaster person who chose to send out an alert warning Hawaii that a ballistic missile was incoming? Was it, I think it's a gentleman, was it his fault? I think it's overly simplistic to say yes. Because if you have built a system where it is one click to send out a ballistic missile warning to an entire state, and it is one person who clicks one button, no double checking, no four eyes principles, no nothing, and that goes out. Not only that, it goes out and it takes you half an hour to respond. Is it the fault of the person who clicked the button? And I would say absolutely not. And I think it is naive of us to say that it is. And it is easy to be like, oh, he's an idiot, blah, blah, blah. Think of yourself in that situation. Put yourself there. Have some empathy for that person. You're in an exercise. You're probably tired. It's probably loud. Do you react in a fully logical way? And most people don't. Had the security of that system been better, there would have been a double check. There would have been a 4 eyes. There would have been an are you sure? It would have gone to a second person, a third person. There would have been an option to recall, and none of those things existed. So is it the fault of the guy who pushed the button? No. Is it the fault of the system? No. The system did exactly what it was supposed to do. You pushed the button, it sent out the message, the system was like, done. From the system's perspective, it worked perfectly. But did it actually do what it was supposed to do? Was there a ballistic missile incoming toward Hawaii? Thank God there was not. But the warning went out. And so it is a failure from our perspective to learn from our mistakes. We have had mistakes before where a person makes an understandable error in a moment of crisis and does the wrong thing. This has happened over and over and over and over again, and our monkey brain is like, yes, but the system worked. Yes, but the system worked. And that is what we remember, yes, but the system worked. And then when we are caught, we're like, yeah, it was that dude's fault. Because our brain is like, yes, but the system worked. And now you ask the developer, they'd be like, yeah, but my system worked. It did. The message went out. Yesterday, there was a hurricane warning that was sent out in northern New York, I think. Not exactly sure. Same problem. No giant storm. No giant storm. So again, on Twitter, everyone's like, there's no giant storm. Everyone can calm down. Exact same thing. There was a ballistic missile warning. I'm thinking like a month later, a couple weeks. Exact same thing happens again. It was the National Weather Service this time, so it wasn't the ballistic warning service. Exact same problem. This is not, 500 years ago. This is literally weeks ago. You would think that someone would have checked that system and been like, this could probably happen to us. We should do something. But instead, their monkey brain, my monkey brain, our monkey brain, yeah, but the system works. So what is the takeaway that you should get from my talk? My takeaway is remember silly. And silly has become the name of the Enigma problem. So every single time you find a teeny tiny weakness in a cryptography problem or in Enigma or whatever, it's called a silly. And it's C-I-L-L-Y, not S. And it's become kind of this way to be like, stupid people. And I tend to see it in the inverse. I tend to have an empathetic view of that German operator, despite the fact that he was a Nazi. He was in a stressed situation. He probably missed his family. His friends and family were probably dying. I don't care that he was a Nazi. I have empathy for his pain. And in that moment of weakness, he picked, or she picked, it could have been a lady, she picked some bad codes. And had they built a better system, they would have had a check for that. Had we built a better system, a ballistic missile wouldn't have gone out to Hawaii and scared the crap out of those poor people. But we tend to think in a silo manner because the next technology is going to solve our problems because that is an easy thing to think. So I'm going to quote the keynote speaker of yesterday as an ending to my talk as well, because I think he did it so much better than what I was going to say. So I'm going to quote him as the technology stack goes all the way down, but it also goes all the way up. A final thing that I always add is that I am not a developer. I'm not. I can read code, I can audit code, but I cannot produce my own. I never have been able to. My brain just doesn't work that way. And I have had the incredible privilege of working with many, 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 many talented developers who have helped me in forums to build tools and sent me code and done any number of things to help me. And so if you're sitting in this audience, I would just like to extend my heartfelt thank you. Excuse me, I'm getting a little ill, so it's not me choking up, I'm actually sick. I could be choking up, it could be an emotional moment for me. That I really, really appreciate that. I think security gets a lot of credit for stopping, ballistic missiles or whatever it is, but I think that's incorrect because it is not a one-person effort. I think that developers, testers, project managers stop exactly as many security problems as I do, and they should get exactly as much credit as I do. So if you have helped me, if you have helped somebody else, thank you very much, because this is absolutely not something I could do by myself. Thank you.